Thank you, Tis. Welcome, everyone. Thanks for joining our talk. As mentioned, it's about OpenFeature in how to manage feature flags. To kick it off, maybe first, what are feature flags and why do we use them? And maybe a question to you. So, are any of you using feature flags? Just raise your hand. Yes, good number. Any users of OpenFeature? Awesome, perfect. At least some. Hopefully more after our talk. All right, but let's first talk about what are feature flags. Let's probably the simplest explanation. It's a way of altering the behavior of an application at runtime, so without like a redeployment. So you can change a functionality or a look and feel without the need for a new deployment. It's basically an if-else statement, right? But it's a bit more complex, of course, than that. Based on some configuration, you can alter the behavior of the application. And an important point is they are dynamic, so meaning that they're evaluated at runtime, no need to redeploy, to restart the application, at least in the ideal case. That's the way it should be. And another important point also, they should be context aware. Let's say it's not a must. You can have also just static feature flags, but the more they know about the context, it allows to have feature flags based on geography, maybe based on users or other aspects. And so that's basically what they are. So now why do we use them actually? One of the great advantages is that we can roll out new features to a subset of users. So meaning that we can actually have controlled rollouts of new functionality without special deployments. So let's say we have a new functionality. Maybe we want to test it first with a smaller subset of the users. We can put it maybe in place in one geography. And then if that works out well, we can scale it out. Or we can hide work in progress. You're part of a large team that works on an application. Your functionality is not yet ready to be released, but it's already in the code base, so you can disable that functionality using a feature flag, and that way the application can be deployed, but the feature that's not ready is actually not used in production. Also, an important aspect, if a new feature is introduced and it causes some issues, you might be able to roll that back. Just disable the feature flag to avoid any issues without having to do an emergency redeployment. And you can also gradually roll out a feature, as mentioned before in the first point. So you could roll out maybe based on geography or based only on 50% of the users get the new feature, and then you increase that percentage. And the important aspect is that it actually decouples the deployment from a release. So that means you can deploy at a different point in time from your release. Let's say you have to introduce a new functionality at a given point in time. Could be due to new legislation. It might be a rebranding of your company. So I'm sure everybody has seen that when you have to have a product ready at a certain date in time. And you need to make sure that you deploy exactly at this specific time. So it's quite stressful, and you have to make sure that it works. And this allows you to actually roll out the new deployment earlier, but you hide the new functionality behind the feature flag and can enable it later. And if we draw that in a schematic way, this is basically how it looks like. So you have your application. It has certain flags. You can see here, so these are the different flags that need to be evaluated at runtime. And then you have a client that actually controls that tells the application which feature flags are on or off. And then you have a feature flagging service. So this could be a homegrown solution where you control the feature flags, or this could be something from a provider, so they're commercial providers for feature flags that give you kind of professional features like user accounts with certain permissions or workflows for enabling specific features. Let's go a little bit back in time. The year is 1977, so the US is about to launch a satellite, and it's called NTS-2. So it's actually one of the satellites that should test the GPS systems. And not part of the GPS system, but that's a satellite they launched to validate if the GPS system would work. But when they developed actually that system, they were not sure if the relativity theory had an impact on the calculation or not, right? The GPS is highly dependent on exact timing to have the position, and there was some debate. I mean, the satellites, I think they were like 40,000 kilometers per hour, So they travel quite fast. So in the relativity theory, the time should move slower. But the engineers were debating whether that was really the case, where that actually would have an impact on the calculation. And when they launched it, they decided to put in a switch called a relativity switch, or at least some of the reports call it a relativity switch, where they could enable or disable that feature. And because otherwise, if they would have had to relaunch the satellite, that would have been quite expensive, right? And actually, it turns out it has an impact. It's not huge, right? It's 38.6 microseconds per day. So you could say, well, OK, we could have skipped that. Well, it turns out that actually makes quite a difference in precision, right? So you're off by 11.4 kilometers per day. So it's pretty much, it would have been useless without that functionality. So there was not any precise kind of geotriangulations, and we would not have the GPS system that we have today, of course, because you couldn't do navigation with that. And so that's kind of, at least I called it a feature flag. I thought it was quite interesting because it shows kind of the importance to launch something where you have the options to alter the behavior as it's deployed.
Yes, so now let's talk about OpenFeature. So what is OpenFeature and what is it used for? And to answer these questions, let's have a look at how your code would look like if you are using some feature flags and some feature flag providers in it. So here you see some code snippet of some well-known feature flag platform vendors like Flagsmith, LaunchDarkly, Flip.io, or Flagship. And what you see in there is they all use different ways and different kind of code how to instantiate their individual feature flag provider clients, as well as how to individually access and retrieve the individual feature flags. So you will end up with a lot of provider-specific code in your code base of your services. And it would even look pretty similar if you're using some kind of homegrown solution, like a config file or a custom database, which you use to store and access your feature flags. It would look pretty similar, so a lot of provider-specific code in your implementation. So now imagine that you have 3 different teams in your organization that all use the same feature flag provider, tool X. So this could be because of some internal guidance or even some policies to use that specific feature flag tool X. Eventually, it offers all the needed feature, and it works great, and the developers prefer to use that tool. So everything looks pretty fine in this world, so all the individual teams have the provider-specific code of that tool X in their services. So now imagine that this internal guidance or best practice is going to change, and they now decide to use and go with the feature flag provider tool Epsilon. So in this case, because of all the feature flag provider-specific implementation in the code of all of these different services, the teams would actually need to change this implementation and switch to the feature flag provider tool Epsilon in that case. And of course, that's a lot of work that eventually needs to happen just to move between provider eventually, because the provider tool Epsilon offers some cool new feature. It is cheaper if it's a proprietary vendor, or it is open source and you want to go with that. Now let's have a look at a more, let's call it realistic example, in which the teams kind of organically adopted the feature flags they want to use in their system, and it decided to use various different feature flagging tools based on the maturity of the individual services, based on the feature they need. And here the teams would implement the specific code of the different feature flag providers in the different services. And switching between providers would be as hard as in the previous example. Moreover, developers from one team wouldn't be able to switch as smoothly and as easily to another team, because of course they would need to learn that feature flag provider, what are the features it offers, how to integrate it, what are the APIs this feature flag tool uses. More importantly, in feature flagging, nothing's the same. So there's no standardization in feature flagging. What are the functionality these feature flag providers offer? What are the providers themselves? What are the programming languages supported? So what would be the better approach here? And the better approach would be to introduce some kind of, let's call it, magic layer between the individual services and the feature flag tools. So this would allow you to easily switch between providers as your services mature, as you need other features from feature flag providers. And you could develop and maintain your services decoupled from the individual feature flag providers that you use or eventually use in the future. And I call this the magic layer, but to be honest, such a layer is not rocket science. Could you develop such a layer yourself? If you're a developer, of course you could. But again, it's time, it's effort just to develop it and maintain it. And that's exactly where OpenFeature comes into play, because OpenFeature offers you and provides you exactly that layer. So OpenFeature is an open standard that offers you a community-driven and vendor-agnostic API for feature flagging that hopefully supports your favorite feature flag management tool. The whole project has been started back in February 2022. There are over 20 plus founding companies involved, like feature flag platform vendors, software delivery companies, or end users. So end users are companies heavily using feature flags. And in the meantime, OpenFeature is a CNCF sandbox project. So OpenFeature itself is not a feature flag provider. It really is the standard. It is cloud native. It is extensible, so you can add support for your homegrown solution, like your configuration file, like your custom database that you use to store and access your feature flags. As it has it in the name, of course, OpenFeature is completely open source. It offers a wide variety of SDKs and APIs to support your favorite feature flag management tool, or to be able to add support for you for your homegrown solution. So here on this slide, you see a few of the founders and adopters of OpenFeature. You see in there well-known feature flagging platform vendors like Flip.io, LaunchDark, Flagsmith, and many others. Or you see companies like eBay in there, who were heavy users of feature flags already in the past, who were a founder of OpenFeature as well, and are now using and adopting OpenFeature. Or you see Dynatrace in there as a vendor in the observability and monitoring space in there, as one of the founders of OpenFeature as well. And we will come to the topic later why OpenFeature is important to Dynatrace. So now let's have a look at the code snippet, so how your code would look like if you're now using OpenFeature. And this is a simple, easy code snippet, how to retrieve and get a simple Boolean feature flag with OpenFeature. So what you see here is in the first line, we just tell OpenFeature which provider we want to use. So here we're using this my provider, so I guess it's some custom provider that we made for our custom homegrown solution, but it could be any vendor provider as well. And then later in the code, we just tell OpenFeature to go and we use this get Boolean value method call to go and resolve us this feature flag with the name with cows. So this get Boolean value method call is never ever going to change regardless of which provider you eventually use in the future. And the provider itself is then the translation code that translates this generic get Boolean value call into the feature flag provider specific APIs and interfaces. And don't worry, you don't need to write eventually the providers yourself. If you're using a well-known vendor, the vendors and community provide you these providers, so you don't even need to learn their individual APIs. Speaking of the tools, vendors, provider that OpenFeature supports, it's not that OpenFeature came along and told everyone, this is how you do it, this is feature flagging done right. Because as you saw before on the slide, OpenFeature has been developed with the industry together. So it's almost certain that OpenFeature already supports your favorite feature flag management tool, whether it is proprietary or open source. And as mentioned, there are a lot of programming languages supported via an SDK so that you can build support for your homegrown solution as well. And with that enough with the slides, let's head into a short, quick and easy OpenFeature live demo. So here you see a QR code that you can scan if you want to, and with that you can actively participate in our live demo as well. So let's jump directly into the demo. You should see here the QR code as well.
Otherwise, just reload it.
I can just quickly add it from here.
There we go.
Perfect, thank you.
Maybe try to move this.
Good. So we're using this Fibonacci calculator web application for our demo. So you see here on this web application, on the top left corner, this welcome message, Fibonacci as a service. And then here on this application, what you can do is basically calculate a number in the Fibonacci sequence. So with these arrows here, you can select which Fibonacci number you want to calculate. So here in this example, we calculate the 40th Fibonacci number in the sequence. And by clicking in the middle or tapping in the middle, the calculation then starts, and below you will see the result. And on the right-hand side next to it, you see how long does it take. So let's wait here a few seconds until this reloads. I hope this works. Let me quickly reload this. It should take, with this algorithm, around 4 seconds. So I guess we have some issue. That's the problem with live demos. But anyways, the idea would be that you could calculate a Fibonacci sequence number with this Fibonacci calculator. And then on the right-hand side in the top, you see this login button. There you can log in with basically any email address without any password. We will use this later in an example. So this application is based on Node.js and React. It is hosted in Kubernetes in Azure. And of course, it heavily uses feature flags and OpenFeature in the background. So for this first example, let's use the feature flag provider FlagD. So FlagD is completely open source. It's kind of like a reference implementation of the OpenFeature standard. And it runs in this example as a standalone Kubernetes pod. So we're using FlagD here to alter the behavior of this application without redeploying anything or changing anything, any code. So yeah, I don't think that this is going to happen, but let's jump into the configuration of FlagD. So FlagD uses a JSON configuration file. It supports other types of configuration file as well as custom Kubernetes resources to specify your feature flags. And here in this JSON file, we have now our flags configuration of FlagD. So here, for example, we have our first easy Boolean feature flag that we specified, which has the name new welcome message. So we tell OpenFeature that this feature flag is enabled. So FlagD should evaluate and retrieves us a value for this feature flag. And we simply specify the variants of this feature flag. So here, on and off, so true or false for this Boolean flag. Then we can specify in FlagD the default variant. So currently, it always returns off as the feature flag value. So we see here we have this welcome to Fibonacci as a service as the message. So let me quickly change this configuration file to on. And now if we go back to our application, at least that part works, we should now see this new welcome message method at the speed of the internet. Of course, that's relatively easy, but you can use this for other use cases to hide eventually complete features, complete behavior of your application from your user, and then enable it if everything is ready. Next on, we have this hex color feature flag, which is in this case a string feature flag. So again, we define a different variants. So here we have red, green, blue, and yellow, and it will return us the hex color codes of these colors. Again, it is enabled, and currently we're returning the red variant. So as you might have guessed, this is the background color in our application. So let me quickly change this to blue. And now every one of you, and as well as me myself, should get now the blue background for our application. Now I want to show you how this looks like in the code of this application. So let me switch over here to Visual Studio. And here we have a evaluate UI flags method for our front-end application in React. And what you see... Yeah. I'm not a Mac user, so... Good, perfect, thank you. Good, so here we have our OpenFeature client. And there we're using this getBooleanValue method call to retrieve us this new welcome message. We specify the default value with this false that gets returned. For example, if our feature flag provider is not responding, so if the flag depot has any issues. And then here we have the second feature flag evaluation. Here we want to get the string value of this hex color feature flag. Again, we are specifying a default value, which is a gray dashboard. And OpenFeature supports for you to use hooks in there, so you can decide to use before or after hooks for this feature flag evaluation. So here in an after hook, we just try to find out if the string value that comes back from, in this case, flag D or any feature flag provider is really has really this hex color pattern. If not, we just throw an error, and in the last step here in this method, we then change the state of our React component to these individual feature flag values. So relatively easy how this looks like in the code. So now let me go back to the flag deconfiguration. Let me reload this here. So I guess everything is dead right now.
So maybe sharing using QR code was not a good idea. I crashed our small demo instance.
So could you please for a moment stop to reload and then calculate?
It changed to the wrong provider.
Ah, okay.
Maybe. You got a number?
Ah,
perfect.
Okay. So you crashed it then. Okay. So let's quickly wait here a few minutes.
Okay.
And now we changed again the provider.
Oh, yeah.
So anyway, let's talk a little bit about other things you could do with FlagD as your feature flag provider. So with FlagD, you could specify easily in this JSON file, and we will send you a link to this whole demo environment where you can pull it from a Git repo and can run it on your own to test these things out. But basically what you can do in FlagD as well is specifying targeting rule. So eventually you don't want to change the background color for everyone or enable a feature for everyone, but for a limited amount of users. For example, your early access program users or your premium users or whatever. And to be able to evaluate that, you need to have context information. And context information could be the logged in user, his email address, his status, whatever, or any other information that you would need to evaluate your feature flags. And OpenFeature, as well as FlagD in our specific example, supports that. So what you basically do, and at least the code loads, if I go here a little bit down, we have here the onLogin function. And what you should see here in this line is that we tell OpenFeature to set a context. And from there on, OpenFeature will use this context and send it as well to the feature flag provider, so the provider has all the information to evaluate the feature flag. So in this example, we would set the context after the login to the email address of the user. And then in the targeting rule of FlagD, we could use this information to then, for example, say all the users with a specific email address, with a Dynatrace email address, these are internal employees, so they should get a specific feature flag value back. So you want to change the behavior of the application based on that.
So we just move on then maybe.
Yeah, just another thing to mention about FlagD. What you can do as well is using it, for example, for A/B testing. So you can specify that 50% of the users should get the blue background and 50% of the users should get the yellow background. You can do this for A/B testing. Of course, it would then be important that you be able to observe what is the impact of a feature flag change, and we will come to that topic later regarding observability. Important notice here that the feature flag provider that you use should be sticky in that example, so that the user one always gets the red background, and not if it changes between screens, the screen background color changes all the time. That's the case actually with FlagD. So we're using OpenFeature, so it's not that we want to stick to flag D, but we could easily change to a new provider.
And here's an example. So we cannot switch in the demo now because the demo crashed, but basically we could just switch it over to, for example, Flagsmith. So pick just this as an example. That's one of the commercial providers for OpenFeature, so, or for feature flags that supports OpenFeature. And you can see it's a bit nicer for users to change things here because you have a nice UI. You don't have to do it in JSON. And we can see the different feature flags that we have. So for example, we could change the algorithm. We should have done that in the beginning because we have a much more performant algorithm. I think the slow one crashed it. So maybe at the end we'll be able to show it. But basically you can use the feature flags here to change the algorithm. So it would be maybe to introduce a new algorithm that the team developed, but you're not sure if there's many users clicking it, if it will crash like today. So then you can switch back and forth. Or more on the UI side, as we saw, like changing the color, or changing the welcome message. And of course, if you're using one of the commercial providers, you will get a lot of additional features, so we can tag things. So for example, we flag those as safe to change. The algorithm might have an impact, but you can change the color, or the welcome message shouldn't have an impact on the application performance, for example. And here you can also, if I select this one, then for example, do segment overrides. And you can say, well, we want to have segmented kind of feature flags, meaning that 25% of the users would get specific colors. So you can change, for example, that maybe for A/B testing, or maybe just because you want to randomly show something different to the users. So you can use that kind of functionality. And then you can also use things like scheduling. So you don't want to, if you have to make a change in the middle of the night, it's nice to be able to schedule that, and you don't have to wake up anybody in the middle of the night. Or also, what could be quite important is that you have like some sort of permission system. So if somebody changes a feature flag, maybe someone else needs to approve it, right? So that we don't make changes to production just right away. And you can have different users with different permissions, so allowing you maybe marketing can change that, what we call the safe features, where they can change colors and stuff, and or people would change maybe the algorithm in the background and stuff like that. All right, let's move on. Yeah, now why Dynatrace talks about OpenFeature? Why did we also participate actually in launching the OpenFeature solution? We're quite a big company, so we have like 5,000, or I think not 5,000, maybe 4,000 developers working on one single product, and we use feature flags heavily inside Dynatrace. One is we have some early access features that we want to hide between feature flags that we only enable in certain environments for certain customers. We of course have to be careful what we introduce as new features, because our agent gets deployed into production environments from very large customers, so we cannot just change the behavior of the agent. It might have an impact, so we can hide things behind feature flags and introduce it gradually. We use also to roll out new functionality, as mentioned, so it doesn't have to be rolled out from a release, so when it's deployed, but we can roll it out later. Or we have some certain functionality that we only use internally, so we don't want to expose that to the customer. And we can do some, of course, experiments as well with kind of experimental features that we want to hide between feature flags. And the other important aspect, I mean, one thing that we like to do at Dynatrace is observe things, right? We're an observability company, and when you have feature flags that you can change, it means that you alter your production environment, right, on the go. And of course, you need to be able to measure what the impact is. If, for example, you switch a feature flag and then CPU goes up 80% or it crashes your demo system, you would like to know, right? So you have to be able to see if a change in the feature flag had any impact on your systems. And there's another open standard, which is called OpenTelemetry. Hopefully, at least some of you heard about it. So it's an open standard for observability on how to collect metrics, traces, logs from systems. And OpenFeature actually adheres to OpenTelemetry. So meaning with, when you use OpenFeature, it will also generate kind of metrics and events and traces to show you what kind of the impact of feature flags. And now just going back to our example, if we look at, of course, we're instrumenting this in Dynatrace, and of course, I'm getting logged out, so bear with me a second. So if we look at the system that we have for our demo, so it's this OpenFeature demo. It's a Node.js service that we have, and So you can see, well, yeah, something went up here, so there's probably some issues. We can see it right here. Also here we see some spikes. But let's look at the service flow. So basically it's several services that communicate. So we have the OpenFeature demo, which is the UI that you clicked on. And the UI actually calls this Fibonacci service, which calculates the Fibonacci number. And if you look at the traces now of the calls, yeah, okay, we can see the response time went up here quite a bit, and you can see the individual requests going to that service. Yeah, some failed actually, as was probably ours. And then we see some others here, so we can look at the requests. And now here you can see actually the OpenTelemetry information showing in. So with this icon, so that's that you have the trace that Dynatrace collects, and then it has added information from OpenFeature. And for example, what we can see is also when it calls flag D, we for example see which algorithm was used or which flag D which OpenFeature provider was used, and we can evaluate those attributes. So we have them as request attributes, and that allows us to see if there was any changes. And of course, we can then, for example, create a dashboard where you can see the impact of a feature flag change. Let's go. Oh yeah, this one actually, the graph doesn't look good now because we have like slow response time, so we don't see what was before because it was quite lower. And we can see actually the algorithm, the influence it has. So for the demo, we were on that recursive one, which is quite slow. And we have actually a second one that we were not able to show because it crashed, but that's much faster, right? That has an average response time of 6 seconds. So that means you can quite easily measure when you change the algorithm, what's the impact. Or you could also look at maybe if switching the OpenFeature provider, if that had an impact on response times, right? Maybe there's some issues with a communication with a provider or something that might have an impact. You never know, it shouldn't, but it's always good to be able to kind of observe things and make sure that whatever you changed didn't have an impact on your production system. Oh yeah, that was the demo time. Back to you.
So perfect. If you're regardless of the Roten demo, convinced now to start using OpenFeature, here you will find some information. The most important link is this openfeature.dev. There you land on the landing page of OpenFeature. You will find all the documentation, all the providers listed there which are supported. Of course, as OpenFeature is completely open source, you'll find here the GitHub link. You can follow it on Twitter or X or whatever. And there is actually a Slack channel which you can use to communicate with the collaborators and developers of OpenFeature. Or just if you have any questions, drop us an email. Either we can answer it or we can connect you with the right guys internally that can hopefully help you. And then otherwise, you have here the QR code to scan if you want to try out the demo. How it should work, you can do that. You can just simply pull this repo, do a Docker compose up, and just play around with OpenFeature. And with that, thanks for having us. Thank you for being here. And yeah, have a nice rest of the conference.
Thank you very much, Robin and Nicola, for that very insightful talk. Are there questions from the audience? There is one over there. Actually, I won't attempt to fully throw the cube.
Yeah, so I wanted to ask, if you're evaluating multiple feature flag providers, can you do that with a feature flag?
You mean doing the evaluation part of like which provider you want to use? Was that the question?
Yes, I'm not entirely serious, but
Yeah,
I thought I'd ask anyway.
But you can do it, yeah, for sure. Actually, our demo would allow you to do that. Let's try if it actually came back. Maybe, because actually what we had here, you could on the fly change the provider, right? But yeah, again, we crashed it, sorry. We should have scaled out a bit more our pods.
I mean, we thought about it, that it could crash, so we scaled it up a little bit, but it wasn't enough.
We blame Microsoft, right, for AECAS cluster.
Yeah, sure.
Further questions?
You mentioned it would be possible to also use file providers. And is this already is there already a file provider, or would it have to be custom made for just trialing teams with feature flags or something without setting up a whole service?
I mean, actually, we just checked today if there is one on the official OpenFeature web application. That's not the case yet, but I guess you will find on GitHub some open source repositories that actually have a provider just to easy access and store feature flags in a config file, or you could easily do it on your own.
Okay, and very short follow-up question as well. Things like GoFeature or whatever, which is an open feature flag provider, you just have the feature flags in code. And I'm not quite sure, because in some way it would be very nice to have the feature flags in code as well, but a large part of the advantage of feature flags is the approachability for non-developers to also be able to release software, as an example, not just developers. What do you think is the better there, to have them as code or in UI?
I think it really depends on the maturity of your services. So back in the days as a developer, I oftentimes started with, for example, using feature flags as environment variables. So it was not possible to change it in any UI or whatever, or it's in simple files. So marketing or the PO was not able to change them. And then later in the project, the pre-PO approach, the development team, okay, I want to be able to switch that functionality. I want to be able to do that. And basically in the past, what we did is we then built a custom admin interface, whatever, so that he gets a login and can do this. But if you're starting using OpenFeature right at the beginning of your project for your environment, for accessing your environment variables, the moment in time this request comes up, you could just switch to another provider, a proprietary or an open source one that actually support this feature to have a UI and do this stuff.
Okay, thank you.
Further questions? Maybe I have one.
There was one, I think, in the back there.
Okay, I'll pass it to you. So what recommendations do you have for conceptually for stopping feature flags degenerating into just plain application configuration that is just accumulating in a very unstructured way?
So I'm not sure if I got your question right. So how to use feature flags to stop accumulating like environment variables or settings like that?
My question is more, what's the fundamental difference between just plain application configuration and feature flags?
I mean, the main difference is if you have an application configuration, usually you have to restart the application, right? So it will read on start. And of course, there's stuff that doesn't make sense in feature flags. You might have like tokens or like environment configuration that will not change. So that makes a lot of sense. But then, of course, everything that you want to change as the application is running, that should go into a feature flag. And it could also be kind of a transition, right? You might have environment variable files, like as you mentioned, and you start with that, and then you actually start adding feature flags, right? Instead of reading the environment file, you provide the environment file as a feature flag provider. And then you can start implementing that in the code. And at some point, you might want to have a UI. So at that point, you can just switch the provider, and you don't have to change the application. I think there's always like an evaluation. It's probably a very good question. What should be a feature flag, and what should just be a configuration? And there's certain things will be very clear, and certain things will probably more be a gray area.
Cool, thanks, makes sense. So Joel had a question.
So yeah, thanks for the talk. I was wondering at which point of time you set an end to feature flags, or like, do you stop using feature flags as soon as it's released for some time, or like, do you do nested feature flags, or is this an anti-pattern? Yeah, like that.
Yeah, actually, yeah, good question. What time do you stop? You mean when you have something that introduces a feature flag, and then at some point it becomes part of the product, right? So you move the feature flag. Of course, I think that's part of the evolution of the product. So you put in it as a feature flag, and at some point it will just be enabled by default because you've made a switch. I think then it's a decision you have to make for a next release. Maybe you remove it as a feature flag. But I mean, I think at least we internally we leave them quite long as feature flags. I think there's like some that we don't remove also for backwards compatibility and stuff. So we have like, that's why maybe also why we have thousands of feature flags. And I think the second question is quite interesting because you might have feature flags that are dependent or that can influence each other's. I'm actually not sure. I don't think there's like a concept of nested feature flags yet, at least in the standard, but that could be interesting. Yeah, if you switch maybe one feature flag, that you then can switch others. But maybe, I don't know if you know, but I don't think there's a functionality for that.
I don't think it is, at least in the standard. And to add to your first question, that's actually a topic at Dynatrace as well, how we handle feature flags that are obsolete now. Because, yeah, of course, over the time, you have some feature flags that you're eventually never going to switch again. And there, actually, we have some lead developers that are now pushing regards that removing feature flags that are not needed anymore gets really cleaned out and removed from the code base. But it's a process. Yeah.
Great, thank you.